Look around you for a few seconds. What do you see? Perhaps you see the inside of a building, including windows and doors. Maybe you see desks and chairs. Or maybe you see books, papers, pencils, and pens. Perhaps you even see other people. Have you ever wondered what all these things are made of? Or have you ever wondered what makes something like this piece of wood different from this piece of copper wire? What's the difference between ocean water and lake water? During the next few minutes, we're going to explore many of these questions and others as we examine some of the fascinating characteristics of elements, compounds, and mixtures. This is a piece of copper flashing. It's sometimes used on roofs to help protect wood underneath it. Let's cut it in half, then cut it in half again, and then cut it in half again. You decide. If it were possible to continue to cut the copper in half, what's the smallest possible piece that we could make? The smallest possible piece is an atom. What is an atom? An atom is the smallest possible piece of a pure substance that still has the properties of that substance. Atoms are the building blocks of matter. All matter, including the human body, is made up of atoms. Over hundreds of years, scientists have worked hard to try to understand the characteristics of matter. This is a simplified diagram of an atom magnified millions of times. One of the many things scientists discovered is that there are many different kinds of atoms. They also learned that the characteristics of matter are determined by the kinds of atoms that are in a specific type of matter. A substance, or a piece of matter that is made up of just one kind of atom, is called an element. Let's take a closer look at elements. What does this piece of gold, this helium gas filling this balloon, and this piece of aluminum have in common? That's right, they're all elements. An element is often thought of as a pure substance because it's made up of just one kind of atom. This piece of aluminum is an element and is made up of aluminum atoms. If we could zoom in on the aluminum atoms in this piece of aluminum, they'd all look something like this. And if we could zoom in on the helium atoms inside this balloon, they'd all look something like this. There are over 100 known elements on Earth. Some of these elements occur naturally. And some of these elements are made up by people in laboratories. Keep in mind that different elements are made of different atoms, which have different structures. And elements cannot be changed into a simpler substance. For example, if you were to smash this piece of iron into smaller pieces or heat it, it's still the element iron. While there are many different elements, a pure form of an element, like sulfur, is rare in nature. Instead, elements are more commonly found linked to other elements. Two or more elements chemically combined form a compound. A compound is matter made of atoms of two or more elements that are chemically bound together. There are millions of compounds on Earth. Many of these compounds are found in living things. And many are found in non-living things, such as these rocks. Most of the foods we eat are made up of chemical compounds. And most of the clothes we wear are made of compounds. Water is a very common compound found most places on Earth. Our bodies need water to survive, and we use it for all kinds of different things. You decide what atoms make up water. Water is made up of 2 hydrogen atoms and 1 oxygen atom. These atoms combine to form the compound known as water. The smallest piece of water is called a molecule. A molecule is the smallest particle of a compound that still has all the properties of that compound. Molecules are made up of 2 or more chemically bonded atoms. A water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. Look closely at the salad dressing in this bottle. Notice how there are many different types of things in it. Look at the particles of sand on this beach. Notice how there are many different types of particles that make up the sand. You compute. How many different ingredients can you identify in this breakfast cereal? There are 4 different ingredients, including oats, sunflower seeds, raisins, and pumpkin seeds. All of these are examples of mixtures. A mixture is matter that consists of 2 or more substances mixed together but not chemically combined. Unlike a compound, the components in a mixture do not combine chemically and therefore can be separated. In a mixture, each of the different substances maintains its own properties. In vegetable soup, for example, there are many different vegetables, including carrots, peas, and celery. Each maintains its individual taste. And when combined with the soup broth, they form a mixture we know as vegetable soup. The rock in this cliff is a type of rock called granite. A close inspection of granite often reveals several different types of minerals. Granite is a mixture made up of several different minerals. You observe. Do the minerals form a regular or irregular pattern? You can see that the minerals form an irregular pattern. A mixture that is not the same throughout is called a heterogeneous mixture. A heterogeneous mixture, such as concrete, is not very well mixed compared to other types of mixtures, and you can see small pebbles and other particles scattered randomly throughout. Oil and vinegar salad dressing is another example of a heterogeneous mixture. If left on the shelf, the oil and vinegar actually separate. Does this toothpaste or this grape juice look the same throughout? Yes, they do. These substances appear the same throughout and are called homogeneous mixtures. Substances such as whipped cream are special types of mixtures called colloids. Colloids such as this gelatin are mixtures in which particles are mixed together but not dissolved. Instead, the particles are suspended and do not settle out. Colloids often appear cloudy, and the particles in a colloid tend to scatter light that enters the mixture. The particles are very small, but large enough to reflect light. In some mixtures, called suspensions, the particles found in the liquid are large and can settle out. Suspensions are heterogeneous mixtures with larger particles. The water taken from this rushing river contains many particles of dirt and soil. If a sample of the river water is allowed to sit still for several days, these particles settle to the bottom. Many medicines are suspensions. There are directions written on the container to shake well. This is because particles often settle to the bottom over time, and need to become resuspended or redispersed before the medicine can be used. You compare. What's the difference between ocean water and lake water? Water in the ocean is salt water, whereas water in lakes is referred to as fresh water. Both are examples of solutions. A solution is a type of homogeneous mixture in which the components are evenly mixed. In a solution, one substance is always dissolved. In the process of dissolving, particles of substances separate and spread evenly throughout a mixture. With the case of a powdered fruit drink, the water is the substance into which the powder is dissolved. The water is called the solvent, and the powdered drink is called the solute. It's very difficult to see the particles in the drink, making it hard to physically separate the solution. Water can dissolve many things and is often referred to as the universal solvent. In the case of salt water, different kinds of salts are dissolved in water, giving ocean water a uniform salty taste. And fresh water is a solution containing many dissolved minerals, such as iron and calcium. Solutions do not necessarily have to be liquids. There are many different kinds of solutions and hundreds of different examples of each. As we just discussed, many things can be dissolved in water. Sugar, for example, is soluble in water. Oil, on the other hand, is insoluble and cannot be dissolved in water. The amount of solute that can be dissolved into a solvent is referred to as solubility. If we were to continue adding sugar to this container of water, it would eventually settle out at the bottom. This is because the water can only dissolve so much solute. In other words, the water cannot hold any more sugar. At this point, the solution is said to be saturated. A saturated solution holds all the solute it will dissolve at a certain temperature and pressure. But by increasing the temperature, for example, the solvent can often dissolve more solute. Other factors also affect the rate of solubility, including particle size and movement. This is just a quick look at the complex nature of solutions. During the past few minutes, we've explored some of the fascinating features of elements, compounds, and mixtures. We saw how matter is made up of tiny particles called atoms, and how matter is made up of different kinds of atoms. We described an element as matter made up of just one kind of atom, and that an element cannot be changed into a simpler substance. We explored how compounds are formed from two or more elements combining. Water is an example of a molecule made up of two atoms of hydrogen and one atom of oxygen. We saw how a mixture, such as this breakfast cereal, consists of two or more substances mixed together, but not chemically combined. We explored some different types of mixtures and their characteristics, including heterogeneous mixtures such as concrete, and homogeneous mixtures such as toothpaste. We briefly discussed the characteristics of colloids, as well as other types of mixtures called suspensions. Finally, we briefly discussed some of the characteristics of solutions. So, the next time you touch a piece of matter, brush your teeth with toothpaste, or mix up some powdered fruit drink, think about some of the things we've discussed in the past few minutes. You might just think about elements, compounds, and mixtures a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. Are the building blocks of matter? Number 2. An is made up of just one kind of atom. Number 3. Water is an example of a. Number 4. A is the smallest piece of a compound. Number 5. Vegetable soup is an example of a. Number 6. Concrete is an example of a mixture. Number 7. A homogeneous mixture is mixed. Number 8. Whipped cream is an example of a. Number 9. In a, one substance is dissolved. And number 10. Water is often called the universal.